Lesson 8.1, this will be on page 797. This is still a part of chapter P. There's two standards we want to discuss in this lesson. The first one, rewrite expressions involving radicals and rational exponents using the properties of exponents. The second one, use a structure of an expression to identify ways to rewrite it. We've worked with properties of radicals in the past. The main ones we've discussed have been the first two. We're going to learn and use a few more now in pre-calc. The first one, if we have the nth root of two factors u times v, we can break that apart into two separate nth roots. We can break that up into the nth root of u times the nth root of v. Second property, if we have the nth root of a fraction, we can break that up into the nth root of the numerator divided by the nth root of the denominator. Third one, if we have the nth root of the nth root of u, we can just simply multiply these two roots together to create one radical. The fourth one, we have the nth root of u raised to the nth power. These are going to simplify each other out and leave us with just u. The fifth one, we have the nth root of u raised to the n power. We can rewrite this in an equivalent form where we take the nth root of u, raise this whole quantity to the nth power. So we're taking this exponent that was underneath the radical, and now we're writing it outside the radical. The sixth one, we have the nth root of u raised to the nth power. This has two conditions. First one, this is going to be equal to the absolute value of u if n is even, and this is going to be equal to just u if n is odd. The reason we have this absolute value condition is, think back to the last property, I could move this exponent to the outside of the radical, so I would just have u underneath the radical. This would have to be an absolute value because in that condition we could not take the nth root of a negative number. Okay, if this n, this index is even. We can't take an even index of a negative number. That's why we have this absolute value condition. Now we're going to go through some examples where we use some of those properties. We want to remove factors from the radicands, so what's underneath the radical. Just like when we started with square roots in Algebra 1, we were looking for factors that were perfect squares. Now we want to look for factors of 80 that are perfect fourth roots. So we have to be a little more creative, but I can break this up into the fourth root of 16 times 5. The reason I'm picking 16 times 5 is 16 is a perfect fourth root. So now using one of our properties, we can break this up into the fourth root of 16 times the fourth root of 5, which the fourth root of 16 is just 2. So our final answer is 2 times the fourth root of 5. In the next example, we have the square root of 18x to the fifth power. So now we want to look for factors of 18 that are going to be perfect squares, and also we are going to break apart this x to the fifth power. Recall that if we have a square root, our index is understood to be 2. So I'm going to break 18 up into 9 times 2 times, now we're going to break x to the fifth up into x to the fourth times x to the first power. The reason we're going to do that is because if this is an even degree, or an even index, that will go into x to the fourth evenly and create a perfect root that we can cancel out. So now if we do some rearranging, the 9 will simplify and the x to the fourth will simplify. So I'm going to combine those together. So I have 9x to the fourth times 2x. Now we can use one of our properties to break this radical apart. We can rewrite this as the square root of 9x to the fourth times the square root of 2x. The reason we broke this apart, the square root of 9x to the fourth, if we're a little creative, 9x to the fourth is the same as 3x squared, quantity squared. Then times radical 2x. We know the square root and the squared cancel each other out, which leaves us with 3x squared times the square root of 2x. And that is now our simplified form. Next, we are going to discuss rational exponents. So the definition, if we have a raised to the m divided by n power, we have a fraction as our exponent. There's a couple ways we can break this apart. In the denominator, which is n, that becomes the index of the radical, and then we could take what's in the numerator and raise that to the outside power. Or we can take this outside power, bring it in, and apply it to the a factor right away. Okay. The only difference, if we have a negative, recall from previous algebra classes, if we have a negative, to make that positive, we have to take the reciprocal, so 1 over a raised to the m divided by n power. In these next few examples, we want to convert between radicals and exponentials. In this first problem, we're in radical form. So we want to rewrite this in exponential form. This radical, if we have no index written in, that's understood to be a 2. So if you want to write that 2 in there, we can. We have x plus y, this quantity. Remember from that previous slide, our index goes in the denominator. Our 3 is going to be in our numerator. So if we combine those into one fraction, it becomes x plus y quantity raised to the 3/2 power. This next problem, we have 3x times the 5th root of x squared. First thing we need to do is rewrite the 5th root of x squared. This is equal to 3x times the 5. Our index becomes the denominator of our exponent fraction. So this is the same as x to the 2/5. We're multiplying two of the same bases, which means we add our exponents. So we have 1 plus 2/5, which we can rewrite. This is the same as x. 1 is the same as 5 divided by 5, so that's our exponent, times x to the 2/5 power. Now if we add 5/5 and 2/5, we end up with 3x raised to the 7/5 power. In this last example, we have x to the 2/3 times y to the 1/3. We want to rewrite this in radical form. If you notice, those fractions have the same denominator. So we can bring that out of both of those fractions. So this is going to be equal to x squared times y to the first. And then that is raised to the 1/3 power. Now we can take that 1/3 power and write it as a radical. So this is equal to the cube root of x squared times y. And now we have this written in radical form. In this next example, we want to simplify the exponential expressions. So we have x squared y to the 9th, that quantity raised to the 1/3 power, times xy squared. First thing we need to do is apply this exponent to both of these factors inside the parentheses. So 1/3 times 2, we have x to the 2/3 power, times 9 divided by 3 is going to be y cubed. And then that's multiplied by xy squared. Since we have a common base, we have x to the 2/3 times x to the first. We add those fractions, 2/3 plus 1. That will be x raised to the 5/3 power. Y cubed times y squared, add the exponents, 3 plus 2, we get y to the 5th. And that's our simplified form for that exponential expression. In this last example, we are going to be combining radicals. In order to combine radicals, we treat that like terms. We have to have the same radicand, which means the same value underneath the radical. So first, we need to simplify radical 80, and then we need to simplify radical 125. So I'm looking for factors of 80 that have a perfect square. Well, I can break this up into radical 16 times radical 5, and then minus, if I want to break the square root of 125 up, I know that's the same as 25 times 5. Each of these we can simplify further. The square root of 16 is 4. 4 times 2, we have 8 radical 5 minus the square root of 25 is 5, so 5 radical 5. We have the same radicand, the same number underneath the radical, so these are like terms. We can combine them by subtracting the coefficients. So we have 8 minus 5, we get 3 radical 5.